Hello everybody, we're going to be talking about the sensory system touch, and one way of thinking about it is that touch is coupled with pain. And we have this chemical here called capsaicin, and this chemical is found in chili peppers, and when you consume this chemical you have a series of events that cause pain-like sensation. And this is probably the best way to try and conceptualize how touch or pain is basically sensed by your nervous system. So this molecule, capsaicin, is actually received by a receptor on certain cells, and this receptor is called BR1 or vanilloid receptor 1. And what happens when this receptor comes in contact with this chemical, there is a large influx of calcium from outside into the cell through an ion channel that is within this receptor. So within this receptor, if we look at the membrane of the cell, we're looking at like a close-up view of what's actually happening. There's the structure of the receptor has on the N terminus these 3 ankyrin repeats, and then has 6 transmembrane alpha helices, which I'll draw here. And then here is where the actual ion channel is, which allows the calcium to go in. And this ion channel opens when it is bound with capsaicin. And what happens, so this would be the C terminus. So what happens when there is a large influx of calcium in these specific cells? So the specific cells that sense this molecule are called or I guess another way, there are specialized cells that have these receptors called nociceptors. And these cells receive this signal, and I'll draw out a diagram showing this. So nociception or nociceptors. Receptors. So if you were to look at, say, your skin, you have these receptors. You can think of these are the receptors for the nociceptors, and then they go into what's called sensory ganglion, and then this goes to your central nervous system. And then this is where the signal is received in your central nervous system, and then you either feel sensation of touch or pain depending on the amount of signal received over here. So this is where the capsaicin is bound, and then this leads to a calcium influx, and then that calcium influx causes a current differential from inside the cell, and then that signal is then transmitted from the point of contact to your central nervous system. And another thing to think about is that these receptors also respond to pH. So if we draw a graph with current on the y-axis and pH on the x-axis, and as the pH decreases, these receptors or cells start to increase their calcium intake, causing current to go up. And then you could also, these cells are also responsive to temperature, and as the temperature increases from a non-physiological or higher than physiological temperature of like 37, you start to feel something's getting hot. So and then one more point I want to make is that you can actually use this chemical for pain management so that you give this chemical, and then prolonged exposure to this chemical actually desensitizes these receptors, and then you have basically less of these receptors which get internalized, and then they're no longer sensitive to this chemical as well as other pain type chemicals.